working? I think this is working. Hold on, let me just check on one of my streaming services. Oh my gosh. Wait, I really hope I didn't do that. Yeah, I was getting like a bunch of random. I was trying to open YouTube and then it said, blah, 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 we have terms and conditions and stuff. And then I'm like, wait, did I just accept the update for my iPad, like, while I'm trying to, stream stuff? But it looks like I did not do that. Let's see. Yeah, okay, yeah, I can hear myself in the YouTube stream, so that's good. Okay. So I'm gonna go turn that off so that we don't get, like, double me. Yeah, what's up, goobers? It's very, very, very cold. And let's see, right now I'm trying to figure out how to save the YouTube part of the stream because, so in the stream, we're gonna be doing some R&D on the, what's it called? We're going to be doing some R&D on the forced hydration machine, which it basically whenever you call exclamation point hydrate, it's supposed to dispense water, and I'm supposed to drink it. And so I got it working on Twitch really easily because they have like kind of an ancient IRC based-ish like chatting system, I guess. And it can run completely self-contained on the ESP32, which is the microcontroller that we're using for this project. But YouTube is a bit more difficult, and I had to like make a proxy for I mean, I'll get more into that, but long story short, in testing, I think I went over the daily limit, so I'm trying to figure out how to salvage that, because yeah, I wonder if I can just make like a new project and then just remake the credentials for that. But in case that's not possible for this stream, you'll just have to do the hydrate command in Twitch instead of on YouTube. Hi, what's up? Thanks for tuning in. Yeah, you're on the right platform. I'm streaming to both YouTube and Twitch right now. But the interactive part of the stream might be broken on YouTube, but it'll work on Twitch. But yeah. Oh, okay. It's a good thing that tag works, because I just started streaming on Twitch like a couple weeks ago, and I don't know what I'm doing. So that's good to know that I'm doing something correct there. Let's see. I'm gonna show the setup that we have right now. Okay, so yeah, I completely reorganized my workbench, and even the drawers are nice and stuff. I have all my parts and materials on this side, and I have the tools on that side, for they're both just full of junk. And the workbench itself is cleared. Alexa, set workbench light to white. Oh wait, oh crap, I didn't switch the scenes. I keep getting tricked by the studio mode thing. Okay, where is it? Office view. Or no, avatar view. Okay, there we go. Wait, why is it not showing? There it is. Okay, yeah. So this is the workbench. Spent like a good chunk of the morning cleaning it up. And we have all of the parts and materials on this side, and we have my tools and stuff on this side. Before, both of them were just like full of clutter and junk. So yeah, that's a lot better. Yeah, I'm a software engineer. I've been in my career like 9-ish years, I think. Yeah. And I also build robots and cool stuff like this forced hydration machine thing. But yeah, So this is the R&D stream, so we're figuring out how stuff works. Oh wait. I just wanted to make a new drawing, not a new folder. So yeah, I guess order of operations, because we're gonna need to 3D print some stuff this stream. So I like to front load the 3D printing, or the CAD stuff in 3D printing, so that like, we can just let the print go burr and then work on other stuff in the meantime. But let's see. So, I did some tinkering around before this R&D stream, just since there's like some stuff that's kind of sensitive, like security-wise, I didn't want to show the screen capture of. So, yeah, let's write down what do we need. Okay, so stuff already done. We have the Twitch hydrate thing working. We have YouTube hydrate kind of working, except I totally messed up on the on that proxy server thingy, which I'll talk about in a bit. Broke. Let's see. I got the ESP32 working with the debug LEDs. I made a scale thingy, but I haven't hello worlded the load cell stuff before, so we're gonna figure that out on stream. 3D print load cell stuff. I tested the water pump. Yeah, I think that's... Oh, and, I pre-printed a bunch of connectors for the frame, because this is going to be a pretty large scale-wise project, like, in terms of we're definitely not going to be 3D printing this during the whole stream. So, I'm going to be prototyping with 2020 extrusion that I just have, like, laying around from other projects. Bless me. So 3D printed 2020 connectors. Yeah. Okay, so I guess I'll go switch back to the workbench view. Okay. So yeah, stuff that's already done. Let's see, if you type in that command for hydrating, let me force it on the workbench view. Hands of shit. There we go. So, actually that light might be too bright. Let me turn that off. Okay, there. You should be able to see when we do hydrate. The Twitch bot responds with dispensing water, and that little blue light comes on for a bit. So it's not actually dispensing water right now, obviously. That's just kind of like a placeholder. But yeah, we have 5 RGB LEDs on here, and they already tell the status of what it does right now. So right now we just have some super basic functionality. We connect to Wi-Fi. While we're waiting to connect to Wi-Fi, let me restart it actually. Yeah, there it is. And then switch back to the workbench. So green light, wow, that was actually really fast. So the green light means that we're connected to Wi-Fi, and the purple light means that we're connected to the Twitch chat. And there's supposed to be a red light when the YouTube chat stuff is working, but it's broken right now, so it's not gonna work right now, and you might just have to wait till the middle of the stream to get some YouTube API credits back. But yeah, so what do I mean when I'm talking about the YouTube credits? Okay, so basically the way this thing is supposed to work is we have YouTube chat, and we have Twitch chat, and we also have my Discord server, which I'm planning to add a bot in there for that. And so with Twitch, that can, I guess here I'm also going to draw. So this is going to be the controller inside of the this thingy that we're making. So then that's the ESP32. So the Twitch chat is just directly connected to that over Wi-Fi, and we just listen for Hydrate. But with YouTube and Discord, the device can't directly connect to the chat. So I have to set up a server for both of them that talks to, and then the ESP32, which is basically like the computer inside of this thingy that we're making. That is that talks to the proxies for that. So YouTube proxy, and this is the Discord proxy. But the problem is that I talked to this way too much, and now Google is mad at me because I talked to them too much. I mean, by mad, I just mean I hit the limit of how many times I can ask it for things, for new chat stuff. So, yeah, I can ask it 10,000 times a day, and in the test program, I accidentally let it run for several hours while it asked every 10 seconds, I think. And I think it actually asks every 1 second if there's like an error, which happened when I stopped my test stream. So, yeah, now we're at 99.73% of all of our asks for a day, now, and that's annoying. But the good thing is that Twitch works at least, so, we can at least do stuff on Twitch, and depending on how the queries per minute, or queries per day thing, expires, we might be able to get some just as the stream goes on, like, if we get back, like, a certain amount per hour or so. But yeah, that's kind of annoying. But we have a lot of stuff to do anyway, so it's not the end of the world, for that. Although, it would be nice if we could get it working on both Twitch and YouTube. But let me just check again. Nope, I still exceeded it. I might be able to get around it by, like, making a new project and just calling that one, but, I don't know. That'll also be kind of annoying, because, there's just lots of security stuff that I don't want to show on screen. But yeah, so that's what it'll do. This listens for Hydrate, and it also listens for here. I'll just abbreviate that to exclamation point H. And when it detects Hydrate, then we trigger a pump that dispenses water. But we also have, and this flowchart doesn't really make any sense, like, in terms of standard symbols, so don't try to look for that. I'm just trying to, like, organize the thoughts on here. But anyway, we also have a scale, which is the what's it called? The load cell? Yeah. Load cell. And this tells us if the cup exists on top of the stand, and if we have water in the cup, and if we're about to overflow. Yeah, and then in addition to that, we have LEDs, and we have a beeper, just so that I can't ignore it. But yeah, that's I guess what we're gonna be working on. So stuff to do. Yeah, I'll just start a to-do list. So let's see. We definitely need to get the frame for this thing figured out, because yeah, it's kind of hard to test stuff without that, and that's also going to rely on some 3D printing. So yeah, that's design. Design and print and assemble frame. And so like I said before, we're gonna be using a bunch of like aluminum extrusion and some connectors that are already printed out. So that'll save us quite a bit of time, because I realized that some of the stuff would take longer than I'm planning to stream to print out. So I did that beforehand. And then we need to hello world fuel, not fuel, load cell. Need to be able to trigger the water pump from the ESP32. And with that, I think we're just going to use a simple MOSFET circuit. MOSFET. And then I guess modify program to dispense water. Yeah, that seems pretty reasonable. And we want to do the design and print stuff first, just so that we can do all the other stuff while stuff is printing. But yeah, I guess that's stuff to do. Okay, cool. Let's see. Yeah, that sounds like a plan. Alright, let's get back to the workbench. I think that's working. Let me rotate my monitor. Okay, cool. Alright, so yeah, just kind of a tour of the stuff. Let me go change the lights. Oh no, not that. Just set all of them on. Okay, cool. So yeah, we have a jug of water here, and we have a glass, just a standard IKEA glass. This is the ESP32S3, which is already talking to Twitch, and it's supposed to be able to talk to YouTube, except I kind of messed it up, so we're not able to do that for a bit. Hopefully we can by the end of the stream, but not yet. But this is basically the computer that drives all this stuff. So this is a load cell. It's a scale. That's basically just what it is. And this is the board that it has to connect to, I guess, compute stuff or whatever with the sensors inside. And it measures, I guess, how much strain there is between, like, those two chunks of metal on here when this, like, when some force is pushed down on here. So that's what we're going to be using to measure a couple things, if there's even a glass in the first place to dispense onto, and how full that glass is, so that we either stop it from overflowing and we just queue up more water after it's done, or we let it overflow because it's funny. Oh, I forgot. I guess we also want to have a water detection circuit, just maybe, or not circuit, sensor, just down here, so that if it does overflow in overflow mode, then we know it's doing that, and we can make it, like, scream and stuff. Okay. And so the other part, so this is the water pump, and it's USB powered, 5 volts, so this thing, or whatever powers this, should be able to power this too. It turns out there's not actually a 5-volt thing that we can tap into here, even when we're plugged into a 5-volt source, because the only thing that could be labeled that, it appears to be only one way, because when I measured it with the multimeter, is at like 0.1 volts instead of the full 5 volts, which makes me wonder how these LEDs even work, because they're supposed to work at 5 volts instead of 3.3 volts, but they're working off 3.3 volts, but we'll have to figure that out also. What else? Yeah, and then here's the 2020 stuff I was talking about. That should probably be enough to build a frame for this thing, and a bunch of 3D printing connectors, plus I found like a bunch of old 3D printer parts that I guess we could also use for that. But yeah, so the idea is we just want the spout to be somewhere where it dispenses water. Probably have some clearance over it so that like you don't hook through that. And have it, eventually it'll be all integrated in one thing, so having this thing be separate. But yeah, that's what we're gonna be making, I guess. Okay, so yeah, I want to front load anything that we have to print. So, yeah, and I could have sworn I had more extrusion laying around, but I can't find it, but I don't think we're gonna need that much. Yeah, we can probably make do, because I have, like, a bunch of random stuff also. But yeah. And, I also got lead-free solder for this project, because we're gonna be drinking stuff from it, so, yeah. I don't want to drink lead. So, hopefully that's not gonna be as hopefully that's gonna be, as easy as, leaded solder, which is my preference. But it's not my preference to drink that. Yeah. Okay, so just mess with the camera a bit. What's the best angle for this? So I guess just have that. And then thinking that the spout is like maybe 100 millimeters or so above that, and yeah, that's plenty. We can adjust that pretty easily. And actually, are these the same length? Yeah, they are. So we also have these bits. So how do I want to do this? Maybe something kind of, actually, maybe, what if we do like a T-shaped thing? Something like that would probably work for now. It's not gonna be the most balanced, but oh, and we can just like slap. Alright, we have these. Yeah, that'll actually be better for, okay, cool. So you know I'm gonna do this. Which one of these is same length? This one's higher. Let's go put that away. So I'm thinking that we just do this. And that should be stable enough to test with. We have, like, plenty of, plenty of ways to attach it with all these, extra thingies. Yeah, let's just do that. Seems easy. Okay. Alright, so... Well, yeah. Okay, no, I think I'm just gonna put it together now. Because what I need a 3D print right now is not gonna be that hard. Is this too long? That's too long. Well, barely too long. How about you? That'll work. But I do prefer it to be a bit flatter. Should I just use... I'll just use washers. Okay. 1, 2, 3, 4. That should be what we need. Okay. Is this the right size? Why is this not going through? Might be too big. Or, yeah, that might be like an M4. Or it might be one of the weird ones that I have that has like glue inside of it for some reason. Yeah, that one's going in nicely. Okay. Second one. Okay, why is that having a weird time? That's not aligned. Okay, I think this is also one of the ones with weird glue on it. That or maybe screw is just sus. No, that one's just going in smoothly. Okay, and then let's make sure that actually fits the way I think it's going to. I think it does. Cool. And then is this head taller? It's not. We're gonna need more of these. Just do 2 of those, I guess. That's actually too big for that. I'll have to do it with some other size. Okay. Rotate this. There we go. Okay, now you can see everything. Did I seriously, like, accidentally mix a bunch of M4 T-nuts in here? I think I did. Yeah, I'm using M5 screws right now, but I think when I was sorting stuff earlier today, I accidentally misplaced some of the smaller sized ones here, which is why those ones aren't spinning on at all. Okay. Jiggle that on. Yeah, that felt weird. Okay, there, that's a lot better. Okay, cool. So we have that part. And then because these are sticking out, we need to add like some feet on this. And I tried doing that with the M5 size, but it was too big. So, yeah, M4 will fit in here. Just need to offset it with like a couple washers. 2, 3, 4. Not washers, nuts. Actually, I think washers would be easier, because I don't have to spin it all the time. Okay, let's put like, probably 4 should work. It's 4, yeah, 4 is gonna work. 1, 2, 3, 4. 1, 2, 3, 4, not 5, I want 4. One, 2, 3, 4. One, 2, 3, 4. Okay, cool. That's enough. We'll put them in all the corners. And this is just a rough prototype. We're not like doing the final design. That'll come in the later streams, but we just want a thingy that works at first, and then we can make it more compact and pretty and optimized. Where did that driver go? There. Okay. Alright. Other side. Working with these camera angles is weird with this phone in front of my face. Okay. So that should be, oops, that's the spout. Okay. That should be good. Wow, that's more stable than I thought it'd be. And then we just need a way to attach this to here. What are our options? Oh, that could be a really good one. Yeah, we'll just use that. That came off of a old 3D printer that I designed. Okay, yeah, let's just do that. Okay, we got the M5s again. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. 1, 2, 3, 4, 5. We don't need all of them though. Actually, I think that's just kind of overkill. I'll just use like one of these plus a T-plate. Did print those up, right? Yeah, I did. Yeah, that should work well. Okay. Just get it started with these two. Put the T-nuts on. Alright. Okay. That did not go in at all. Is this even... Yeah, that is actually long enough. Okay, okay. That is actually in. Loosen that a bit, and then tighten it. Yeah, that's close enough to the middle. Is that in? Yeah, that's in. Okay. And then put this T-plate on. Two more. And a bunch of T-nuts. 1, 2, 3, 4, 5. Okay. Those holes were just a little too small, and I probably should have drilled them out before, but oh well. Alright. Thingy where just shake it till they go in. Cool. Oh. There we go. Is that in? Yeah, I think it is. Alright, cool. I think we have a frame that's solid enough for this. And then... let's zoom that out a bit. And then we need a way to connect this to here. Honestly, zip ties could just work. You might not even have to 3D print anything there. Well, no, I want some space here with the tubing, so... I think that'll be a pretty easy print, though. Pretty easy design. Okay. Let's... set up... Fusion 360 showing. It is. Okay. There we go. Alright, where's the water thingy? Force hydration. Alright. So... yeah, I'm thinking we just do something pretty simple. 20 millimeters. I'll set that maybe like 10 millimeters-ish. And then, what's the... That is 8 millimeters. Let's make that like an 8.5. You know, actually, we can't change the height of that while it's attached. Okay, how about... Okay, yeah, we'll have to kind of hug it instead. Alright. So that's 20. And that's 20. And then I think that we're actually going to do something like this instead. So instead of attaching it so that, like, the, what am I trying to say? Okay, so the front of this is going to be where we want this thing at, but we can't just mount it directly through here because, like, that's in the way of that. So if we want to adjust the height without having to disassemble the whole thing, we'll have it attached on the sides instead here. So it'll be like kind of like the shape with that going on. Okay. Bless me. So let's add a little bit onto that. Let's make you 8, I guess. 4. Yeah, that'll work. And then guess add some grooves here. Let's be 6, or let's make it like 6 point. No, let's make it 6. 6. Doop, doop. Symmetry that. Doop, doop, doop. Symmetry that. Equal. About like just, no. 1.5, sure. And then extrude this up. Doesn't need to be that big. Let's make it like 40, maybe. Let me get like, actually 60. Let's see. Yeah, 60 should be good enough. Okay, and then want to add holes so we can actually screw it in. One, 2, 3, 20. Let's make that 20. And oh no, I want those to be equal. Did I unselect them? I think I did. Equal. And 5.5. And we also need some of that cleared out a bit too. I'm just pulling these numbers out of my memory since I've designed like so many things using this extrusion that I have those numbers memorized. Oh wait. Cool. Yeah, and then that just gives it room for it. And you know, we don't need to even put holes on the other side. We can't even put holes on the other side because the spout's gonna be in the way. Yeah, that should work. And then just pretty it up a little. 1, 2, 3. Yeah, just 4. Yeah, 4 should work. Alright, cool. We can 3D print that then. Oh, no, we need to add the zip tie, thingies. which means that we're gonna have to extend this a little more. Let's make that like 12. Cool. Okay. Sketch. Something just disconnected and got nasty. Whatever. Okay, I want to... Yeah, I'll just line it up with those. That shouldn't be an issue. 2 and 3. Doop, doop. Symmetry. Doop, doop, doop. Where is it? Symmetry. Doop, doop, doop. Line those up. And then, yeah, 2 should be fine for the zip ties. I actually sanity check and measure my zip ties. Okay, that's 2.5, and that's 1. So yeah, with a bit of breathing room for 3 print messiness, yeah, we'll just make that 4. Bless me. And then that can be like 2. Oh, are these not the same length? Not that they would be. Okay, what's unconstrained? Oh, that distance. Let me just make that 40. Cool. Yeah, and that lines them all up. Alright. And then cut revolve those around this. And then that is where zip ties will be wrapping around to secure it. Cool. Okay, now we can probably print them. Well, you just reduce for weight. Not weight, for print time. I could probably be like maybe 9. Oh. And we'll just make that. Okay, yeah, that should work. Cool. Oh, I guess can also fill it that a bit. Won't tolerate that. 3, yeah, 3 should work. Cool. Alright. Yeah, we can route zip ties around the spout, and we can adjust the height via the side entry. Cool. Okay, let's call this spout holder. And then 3D print this. Oh, wait. Wait, did that change? Huh. Why was that not set to Bamboo Studio? It doesn't matter. Hold on. Reprint. I thought I set this up. There we go. Okay. Now we can print that. If Bamboo wants to open. Okay. No. Go away. Bamboo. Where are you? Okay, here's Bamboo. Cool. How long will that take? 20 minutes, that's not bad. And let's get the right filament loaded up. Yeah, let's just use the PLA I have loaded in there. that take longer? Oh well, doesn't matter. Okay, we can print that. Cool. Alright. Oh, why is my face... Has my face been stuck on that the whole time? Okay, there we go, my face is working. Alright, okay, I'm gonna go refill my drink real quick. Okay. Now I'm back. Bloop, 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 bloop. Okay. My arm's disconnected. My feet also? My feet disconnected too. Did my hips disconnect? Yeah. Ugh. Okay, cool. We're back. Alright. So, now that that is done, or that's printing, I guess. What next? So I have the load cell, and I haven't gotten it working yet. I haven't tried yet, that is. And so this is basically just a scale. This thing hooks up to here. Gotta solder that together. And then this connects to that. And then we're supposed to get sensor readings out of it. So, we're gonna go do that. First, we need to figure out how to wire it up. And how do I want to do this? I think I want to breadboard this. Ooh, why did it split like that? It's kind of annoying, but whatever. Yeah, there's like four holes here and like 6 here, but like this thing came pre-split into like 5 and 5, so I have to like break one of them off and just have it awkwardly hanging on the side when we solder it. That's not a big problem though. Might not be able to actually use the breadboard easily because it's too wide. Well, actually we can just put it on this one, because that's like really wide. Or I had to like cut that in half to make it wider. But that's okay. Yeah, I should probably get the Bamboo print view working on that, in that scene. Okay. Workbench, Bamboo picture in picture. And then I'll just move this up to here. Yeah, cool. That'll work. Good enough. Okay. Cool. Now you can see it print while I'm working on other stuff. Okay. That's lined up. That pin fell out. Placed. That one pin that's just awkwardly hanging out. If we actually just put that one in first. There we go. Alright, cool. And I have not used this lead-free solder before, so I hope it doesn't suck. Okay. Heating that up. And then clean the tip. Cool. Might as well flux pen it. Okay. Hopefully y'all can see that. You know, it would help if I had my soldering fan set up. Oh wait, that's gonna... Oh wait. Forgot, y'all are looking at this through a camera, so it's not blinding you. Alright. This is not bad. Ooh, it's kind of spicy though, because normally I use like a much thinner solder. So like, I can actually feel the heat transferring really fast through the reel. Okay, how does that look? I was looking at it sideways. There's a fridge. That'll work. Yeah. A little too much solder on there. I don't know if these are cold joints or if they just look cold because it's lead-free solder. Okay. Cool. Alright. Well, that hopefully worked. And then... let's add some connectors to this. And I'm gonna actually zip tie this around here so that I can't accidentally pull out the wires or something, or if it does, it doesn't tear them out at the root, which would render this thing unusable, I think. So have a bit of like shitty strain relief, better than no strain relief. Okay, cool. have to glue that down, but hot glue gun. Doop, doop, doop. And then while that heats up, I'll just use DuPont connectors since we're breadboarding this right now. Alright, DuPont. Do I have any 4s? Are these all 3s? Are they mixed up? Oh no. Okay, I do have some 4s. Alright, so I should probably look up the wiring diagram for this anyway. Okay. Okay, my face is gonna go dead because I'm checking Amazon real quick for what this thing is even called. Purchase history. HX711. So, HX711. Can y'all see that? I don't think you can see that. Okay, there. Alright, HX711 wiring. Oh, I like this website for tutorials. And that looks just like my load cell. Go back to here. Yeah, it looks pretty much the exact same as on that website. So that's a good sign. Alright, so red is power, ground is output. So I guess we don't actually need those then. That's some weird soldering. Okay. So then that goes out to the Arduino or whatever microcontroller we're using. Okay, easy enough. Or, you know, actually, we don't even need to, like, have this span an entire breadboard. You can just actually put some female pins there, and then just plug that in directly to these header pins. Yeah, let's just do that. Alright, female connectors then. Okay, 1, 2, 3, 4. Move the camera down. Oh wait, actually I should probably just tilt it. Yeah. Yeah, that's better. Cool. And I'm gonna glue this down right now. Okay. Cool. Then I really hope that these aren't actually too tiny to use with this. I have a feeling that these are actually just gonna slip out. Because normally that first crimp is supposed to at least let it have a little bit of resistance. But, you know, we're just gonna be direct soldering this anyway in the final version, so whatever. It's fine. Okay. But it's still not gonna be the best connection that it could be. I could also just put like more hot glue gun glue on there once they're seated in the connector. Could work. Okay, there we go. And then what's the pin out? Red, black, white, green. Red, black, come on, go in, white, I've squished it down a little too hard. Some tweezers. A little long. Green. Yeah, just get that all the way in. Do I want to desolder? Nah, we're just prototyping right now. We don't need to desolder that right now. Okay. So that should be... Actually, fuck it. Let's do it. Okay. Don't need the hot glue gun. Actually gonna unplug the desoldering, or the soldering fan. Okay. So, I'm actually gonna go desolder those pins and put it, do like some 90-degree angle ones instead. Okay, it's probably hot enough by now. Why am I so shaky today? pull them off. Yep. That was good. Cool. Alright. We need to clean it up. Why not? Okay, cool. Unplug that. Move you over here. Sort of out of the way. Alright, where are my headers? We only need 4. We don't need, like, 6. Or, yeah, 6. Okay, 1, 2, 3. 4. Cool. Alright. So... because I want to replace it so instead of it coming out the bottom, comes out and in front, so that's like this now. Although, let me just make sure that's the exact same board layout. Yeah, that is. Cool. Okay, now we can solder that. Where did the... there one. Put you back in. Let me secure it properly. Let me fix that. Could actually just get away with doing that straight up. Wow, yeah, actually does work. Okay, you only need 1 then. One, 2. Can't really see it that well from this angle. And the sliding. No, that's not good. Not sticking at all. There we go. Okay, yeah, that should work. Alright, got this out of my face. Okay, so now that we have these headers on, we can plug it in this way. Yay! And then from there, we can hook it up to the breadboard and just figure out what the wiring should be for that. This is a beeper. So I'm just gonna have this over here. Just gonna glue this down. so that it doesn't come like loose. Alright, so ground and voltage are easy. And let me just make sure that it'll work on 3.3 volts. Here it's showing on 5 volts. Okay, that says it should work. This says it should work. It looks like the same board, just red. That is not the same board. Okay, there are several sources saying that it works on 3.3 volts. So, yeah. That's good. I have like a bunch of random... You want to dig through this mess? No, you don't. Ah! Okay. Whew. One of my boxes just fell, but, like, it was closed, so it wasn't a problem. Okay. So, just getting out my funky wires. And we might need all of them, so I'll just get all of them. Okay. Oop. I think that the water pump control line... Oh, I forgot to turn my face back on. Oops. I think that the water pump control line should definitely be blue. Yeah. And white for weight. Yeah. And then, of course, red and black for ground and power. As is standard. Okay. Doop. Two. Ground. Yeah, I'm gonna strip it a bit more. Seemed a little short. Alright, power. And then... What was the color convention for clock signal? Wire color standard clock. I don't want to use blue. I want to save that for... white for clock. You know, it probably doesn't matter. Let's go with green. Green for clock. Let's make it long enough to reach anywhere we need it to on the breadboard. And then white for weight. Okay. And then we can just... Oh, that's a little off. They're both off! Okay, now those are properly seated. Okay, so we're doing green for clock, I guess. And then DT, I assume, is data. I'm actually gonna go use the further holes just because, I guess there's more leeway if I mess up or something or whatever, somehow. Okay. Clock. And wait. Data. Hot goon gun. Hot goon. Hot goon. Is that visible? I hope it was. Okay. Alright. So I guess we're gonna use this library here. That's weird. Oh, that's because it's on Firefox. Not the whole screen. Okay, that makes sense. Alright. Opening Sea Lion. I still kind of read it as Clion sometimes, but I've been reading it more as Sea Lions, so that's better, I guess. But that is my IDE of choice. Alright. So, let's... Actually, you know, I think we probably do want the desk view. Not desk view, the screen view. Not Sea Lion. Ultra wide. There we go. Okay. That and this. Hold on, I don't want to show my API keys. There we go. Okay. Want that. And we want to include hx711.h. And then Kia run. That should download that library. That's a later project. Okay, so we have that, and there's this annoying bug in, I'm not sure if it's technically a bug, but there's an annoying pain point where, like, when you download a new library, it still doesn't recognize it, so you have to, like, reload the project sometimes. Maybe you don't want the quotes. Okay, yeah. I don't think it matters which pins we actually use for those. So load cell config. Fine. Load cell data pin, and I'm gonna figure that one out later. Define load So let's maybe go with like that corner, I guess, ish. Not sure we can use pins 1 and 2, I guess. That should be fine. Pin 1, and I'll use 1 for clock. Pin 2 for data. Okay. Pin 1 for clock and pin 2 for data. Yeah. Let me just verify. Because the NeoPixel is in 4. Yeah, okay, so that is labeled the way I expect it to be. Gonna plug this in and hope it doesn't blow up. It's not blowing up, that's good. Cool. You know, I should actually probably set up a scene in, what's it called, in OBS, where it's like half what's on my screen and half of the webcam view, I guess. I'll try that out. That might be cool. Hold on, let me set up the scene. Rename avatar PIP. Okay, let's maybe just copy pasta you. And let's put you just right under the avatar. And then let's center that. Or something. Yeah. Where'd it go? And then just maybe make it like half. Okay, this is an interesting, what's it called, camera view. Alright, so let's see. And it looks like our print is finished, so we'll check that out. Actually, we should probably check it out now. Just, in case it doesn't work, we can get the next print started soon. Okay, let's do a bit of housekeeping, because this is a mess right now. No, actually, we're gonna keep you up here, because you're gonna be useful. And I'll clean up all of those. What is that noise? I'll clean up all these connectors because I don't think we're gonna need any more anytime soon. Oof. It is toasty in here, even though it is cold and freezing outside. I feel like we're overcompensating with the heater. Okay. Might as well put these things away too. And you're cooled down. Put you away too. Calipers there. My Apple Watch is telling me that the print was a success. Oh, here's the print, by the way. Let's see. Oh, that's interesting. It didn't automatically switch cameras like I thought it would. Let me make sure the camera switching is still working. Okay, that's interesting. It only does that. Okay. I think I implemented it so that it only switches if we're on one of those two scenes, but not if we're on anything else. So if we're on the halvesies scene, then we won't be switching. That's interesting. Okay. Putting that away. Put you away. Put you off up to there, because it's kind of sussy. You know, I might need a second cup that's like full, or a third cup that's like half full. Just so I don't have to keep like, oh no, I can just have 2 cups and just keep changing the amount of water between. Yeah, I'll do that. Okay, let me go get another cup real quick. Another cup. Another cup of water. Okay, I'm back. All my trackers are good. Cool. Okay. Second cup of water. Put the extra load cell away for now. Alright. Put you away. Let's put these wires over here. Yeah, I like to keep my workspace organized, because when it's not organized, things become really annoying to try to find and stuff. Don't need you. Don't need you. And I'm gonna unplug you just so I don't like accidentally have shorts. Okay, what was it doing? I was testing out the mounting for the spout. So with that, got 3 of these guys out. Warm up the hot goon gun. Need some zip ties. I'll use a tiny bit of double stick tape. 1, 2, and oh, my phone went back to sleep for some reason. Okay, my face should be back. Ew, face. And more zip ties for the zip tie god. Oop. Ah. Okay. It is really warm. I forgot I didn't teach her what the thermostat is yet. Okay. Why are these so whack? I think those are the best ones. Yeah, this is what I meant by, like, there's some of these that have, like, glue on them. I don't know where it came from. It's really annoying. Honestly, 3 of these guys in there might be overkill, but it's okay. Is 3 overkill? Nah, 3's not overkill. We're alright. Okay, so yeah, we can just adjust the height of this however we want. This is why I really, really, really like 2020 for prototyping. Because then we can get the length that satisfies us. Alright, where'd the spout go? Spout, where are you? There. Yeah, that's kind of really loose. I don't want to use this tape, it's too thick. Oop. I have some thinner tape I can use for that. Taking the backing off like double stick tape. Probably be easier if I take it off after it's applied to here though. That works. Is there like a trick to this that I just don't know, that I should really know about for getting backing off these types of tape? Okay. Yeet. It is almost invisible. Alright. I need to line this up with my own point of view. Zip ties, yay! Alright, you have that. Snip. 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 Where's the trash can? There you are. Eat. That ain't going nowhere. Alright. Did I put the tape away? Yeah. Cool. Okay. So I think that works. I don't see any reason this wouldn't work. Actually, there is a reason, but I don't think that it's going to be a thing. Let's put this here. And let's just slide this down. Okay, so we actually are in range in a good way. And I think that that's probably a reasonable height for this. Of course, in the final version, this will all be one piece. They won't be split up like this. Although, I think I'm gonna have to move this thing over because, I don't know how the squishiness of this mat will affect the, weight reading, but did I stop? Oh! Hold on. Did my stream die? Oh no! Hold on. What's going on? Twitch. Pearl for your scars. Okay. It looks like we're reconnected. Not sure what was going on there. But okay, let's get back to stuff. So I don't know how long I've been disconnected. So I'll just explain what I was working on. Yeah, just cleaning the workbench, and I just moved the mat over here because I'm a bit worried that the squishiness of the mat might affect the readings on the load cell. And I adjusted the height of the spout to so that it makes sense with the height of the glass. Not be too high or too low. So I guess that means that we should mess with this stuff. Yeah, I think I don't know if this requires a direction it's supposed to be, or if it can work in any orientation it wants to. So, I'm gonna look that up before I cut any tubing. But yeah, that is the pump, and I'm trying to figure out where it should go on the thingy. Let me look up what that pump was called. What are you, Amazon listing of the pump? Portable USB electric auto siphon self-priming pump for bottling homebrew beer, wine, and kombucha. Okay, so and my face is dead because I'm on Amazon on my phone right now. It's sideways in one picture. It's upside down in another picture. Okay, I don't think it's an issue. Okay, cool. So we can just mount it however we want to. I don't feel like printing out more stuff, and there's no way this thing is gonna be like super duper duper high. So I think that we should just take this, zip tie it up here with some, what's it called, bit of double stick tape. Yeah, that should work. Okay. Let's do that. Double stick tape. I hate removing the backing from it. It's so annoying. Alright. I need some big boy zip ties for this. Should probably just leave this box of zip ties down here. Okay. Which one is in and which one's out? It's marked in Chinese. Okay. Google Translate. Let's have it in... Oh, wait. From English to, I'm gonna assume... Oh. Right, okay. In. Out. Okay, one of those characters matches at least. Because out... You can see that first character and out is here. So I guess that's the output. Actually, there's like pictures on the Amazon that I think would also confirm this. Oh no, Amazon's confirming the opposite. No, it's not. Wait, no! I think that the stock picture actually has it like, wow. Okay. So... And yeah, here's, looking at this. Is this like an infinite carousel? Yeah. Okay, so here, I'm gonna rotate it because there's one that's like kind of more on the outside and one that's kind of more on the inside. So here, the inside is the output. Here, the inside is the... I can't actually tell in this one which way it's going. I guess the spout is the output then. The inner one is the output, but in this one, the outer one's the output. This one, the inner one is the output again. No, the inner... Wait. Inlet sign in, outlet sign out? Ugh. You know, we can just test it also. But, I'm just gonna go with what the marking says here. You got, I mean, I took Japanese, not Chinese, but that looks like two, mountains, stacked on top of each other. Was Yama? Is that mountain in Japanese? Yes! Okay, I'm not crazy. Mountain in Japanese. And that's two of these, and the symbols are shared between the two. So that makes sense. So out is that thingy. I mean, worst case scenario, we can just switch it if it's wrong. I don't think it's wrong. I think that's probably correct. Just tighten that so that we're up against the, whatever that is. And there's not actually room to put a second zip tie in there. Alright, yeah, we can crank it up probably. Yeah, I think that's the most we can tighten it. Snip, snip. Alright. So, let's get some tubing. Looks like I could go from the output to the spout. Or the tubing. I don't want to touch all this stuff that much because it probably has like lead and other nasty things. But that is there. I want to have some slack in case we want to keep moving this up and down. But it's not going to be that low, so that should probably be fine. Where's my scissors? I need scissors, 61. Don't want to be too tight and have like any kinks or something, because then it just won't work. Yeah, that should work. So this... I don't want to cut it up, because you can cut, but you can't uncut. Okay, cool. So we have that pump there. And with that, I am gonna go pee real quick. I'm gonna go pee. Alright, I'm back. Yeah. So, we just hooked the pump up. And we should probably test the pump. So, let me actually go fill one of these cups with water. Water. Getting some water. Okay, I'm back. Yeah, I didn't want to use the bottled water on the desk because, like, it's nice, I guess. I just kind of want to use, like, tap water to test. And, you know, I'm going to move this out of the way, actually. It's because it's just taking up a lot of space. Okay. This has a switch on it. My head keeps bumping into, like, everything. Alright, hope this is the right direction. I mean, if it's the wrong direction, it'll just, like, be blowing, like, bubbles. Oh. It would probably help if that was actually wherever the thingy is supposed to be. Let's elevate that a bit. Alright, let's test this out. Yeah, it works. That's cool. I think something that we do need to be mindful of is, what's it called? The tube is always going to have some water in it until we empty it out. So, if we keep moving this thing around, it'll possibly keep doing water things. And, you know, I think I'm actually going to get, like, a pitcher or something, so that we have a bigger supply of water to test with, and, just tape this tube end to it. Let me go do that real quick. Oh. I do want to keep that water, though. Okay, let me go grab a pitcher. I got a carafe, or whatever it's called. I'm just nervous because I don't want this to spill all over the workbench, because that would be a bad time. Just trying to think if there's a place we can put it that's like super out of the way. Honestly, probably around here, if I get this out. That should be fine, because we don't want to move this around much anyway. So I guess we can just like leave this in here. And then probably just find a creative way to like, not clip, but like, you know, I could probably just like actually just tape that like, I'll move it in view. Probably just tape it around like that. That should be fine. Where's a bit of tape? Gaff tape should work. Yeah. So I guess this is just our, like, water supply. And we'll just keep pouring it back in here when we need to. Are my pouring skills okay? Close enough. Works for me. Alright, so this is our water tank for now. And it will live around here. And this should probably stay around there. I might even just tape it down just to enforce it. You're like, no, don't move it around, because that's bad. Yeah, that's probably a good idea. I'll just tape it down. Let's probably put like a bit of, some like, paper towels in there. I'm doing well, just humming on this project. Wait, did my arms die? I think my arms died. My arm tracking died. Let me turn those back on. So did my feet. And my hips. Like, literally just my head stayed working. Okay. Is this working? Okay, cool. My tracking's working again. Okay, so I think the move is to tape this down so that I don't keep moving it around, and to minimize risk of spilling that. Spilling our water tank. Plus, this is not a bad spot for this anyway, because it needs to be relatively close to the computer to reach the cable to reprogram it. So yeah, you can do that. Just make sure that this water pouring stuff works still. Yeah, Michael Reeves is not a bad comparison for the content I'm doing. We're working on a thingy that forces me to drink water. And I am demonstrating the water pouring stuff right now. Yeah, I think that's a good height and a good position for this stuff. Let's pour you back in here. Probably gonna regret putting this next to the soldering iron setup, but whatever. Alright, and where's the rest of the tubing so I can just like hide it? Oh no, that is the rest of the tubing. Yeah, I don't want to cut that tubing up, because you can always cut, but you can't uncut stuff, so yeah. Alright. What is next? I should probably check on my YouTube quota, since it's been... I'm gonna hide the screen. There we go. Since it's been, like, 2 hours. Cloud, console, Google. And I might have some YouTube API requests freed up. But if not, it's okay. Alright, APIs and services. Requests, errors, YouTube data API v3, quotas. Nope. Okay, I don't think that we're gonna have YouTube working for, what's it called, for triggering the command. It'll only be working on Twitch. And that is definitely my bad for accidentally overloading that API. But yeah. Okay, what were we doing? Okay, so I paused from working on the load cell stuff to make sure that the 3D print was good. And it's good. And then just mounted the spout and the water stuff and tested the pump, and it all looks good. So I think that we can get back to the load cell, the scale. I need to get some paper towels because water around electronics is not a good idea. But I'll just leave this roll of paper towels here. There is almost certainly going to be a spill today. It's just in the nature of this project. Alright. So, the load cell. We just want to hello world it first. We already have everything connected. So we just need to program it, I guess. And we have 5 LEDs. And I think that, I'm just gonna use so, this first LED is for Wi-Fi, second LED is for, Twitch, third is for YouTube. I'm gonna move this one, but the fourth is currently for, water dispensing, and the fifth is for the scale measurement, for the load cell measurement. I'm gonna go move that over to here, and then we'll have this one debug whatever the measurement is for the scale, so that we know if, first off, if there's a cup on here, and second, if the cup has water in it and how much. Oh, and this, I just bought this thing, which is actually a set of weights for calibration. So that should help too. Yeah. I like tanks. Tanks are cool. I don't know much about them, but the ones that I do know I like, and I like to watch Girls in Panzer. I'm actually rewatching that right now. Yeah, let's just look it up. Doop. Okay, we're good. We didn't pour any water on that by accident. That would short that. You know what? Actually, I'm gonna go refill my drink again real quick. Blip. Alright, I'll be back in a minute. Alright, I'm back. And, let me turn my sensors back on, because it appears they died already. What kind of stream is this? It's, R&D, it's research and development. I am working on a thingy that forces me to drink water. and when you type exclamation point hydrate, it should dispense water out. My avatar is going nuts. There we go. We're back. It doesn't work yet, though. We're working on that right now. Alright, so... we have that stuff hooked up. Let's get the code working for it. Alright. Actually, I want to move... no, I didn't even type that in yet. HX711. Let's call it load cell. Alright. Ah! That's a good pun. What are you doing? Okay. Let's do void setup load cell. Yes, if you type in exclamation point hydrate, it will dispense water. That is the intention. Is load cell 1 or 2 words? It's 2 words. Okay, so we're gonna camel case that shit. What is it called? Setup? Yeah. Wait, why am I calling it setup? It should be, initialize. Alright. So that should be load cell dot begin. Where did I define that? Let me split. These screens. Load cell, where are you? You're called load cell, and those are the pins. Load cell data out. Load cell clock. And let's do that shit at the start. Yeah. Okay. Interesting. So what are we doing here? Whoa, that got weird. Let's actually start at the top of the example code. Okay, so scale.begin, and then we'll just have it do stuff regardless of the Wi-Fi loop. Okay, if scale is, oh no, it's not scale, if cell is ready, then interesting. So I guess this is how we're going to get the calibration factor then. Alright. I mean, honestly, I'll just copy pasta this. Except it's load cell, not scale. But it looks like that we have to do it with like some weird timing. But that's okay. Let's see if this compiles. So you do not need permission, but I will be adding safeguards so that, I mean, the reason we have the scale is to make sure that water is not poured when there's no cup, and to also, in safe mode, not keep pouring water, if it's full. Yeah. Also, it's gonna beep really loud at me whenever it dispenses water, and it's also probably gonna keep beeping whenever, there's water I haven't drank yet. Yeah. Okay, it did not like that. Undefined reference to load cell. Did I not save that? Let's try again. Unless... did not... Oh, I didn't do that. Okay. Load cell. What's it called? HX. Yeah. Alright, that should work now. That worked. Let's upload and monitor and see what it does. Hopefully we got some kind of reading. This might be a good time to do the, what's it called? Okay, do we get... yeah, you can do the command, but it's not actually going to dispense water. It'll make the LED go blue, though. But it's not quite ready yet. It does not look happy. Why are you not happy? Socket error. Connection reset to IPeer. Did we ever initialize load cell? Okay, load cell begin. We are initializing that. Let's reset again. Maybe let's set that to, like, higher. I haven't run into this error before. Uploading. Uploading. Should probably turn off that thing that says water every time it loads. But we do know, though, that Twitch is working, though, at least. But where is that connection reset IPeer coming from? Okay, let's see what happens. I'm gonna go switch to the Havesies view and move that LED in view. That is not in view. What? Oh, that's because it's shorted, because it's metal. I'm dumb. I hope that didn't burn it out. That'd be annoying. Shit. That may have been really stupid. Shit! No, it works. We're good. But this time I will put it under the plastic bit instead of under the metal bit. Okay. Well, we did get rid of that water thingy at least. Oh, I know what's going on here. That's the YouTube polling thing, which I'm just gonna... Define YouTube enabled false. No, that's not equal. Okay, false. Define Twitch enabled true. Okay. If Twitch enabled, then we can go do all that shit. And if YouTube enabled, then we're gonna do this shit. It is not enabled. Try this. I just want that error to go away. Alright, let's see what happens on Twitch if we call hydrate. Okay, Twitch light is on. I'll hydrate. Does the hydrate light turn on? Alexa, turn workbench light off. Let's move you right up there. Turn you off also, just so that we can see it better. Yes, hydrate did not work. It used to work. Oh. That's kind of slow, but it works now. But it looks like that the pump never initializes. Do we ever call that instead of initialize load cell? Load cell begin. Okay, I'm just gonna simplify the code here. Well, do we even have, like... Boards manager. ESP2. Okay. So we do have... I'm just gonna take the straight up, test code here. In the super basic, like, Arduino IDE. Why is that taking forever? Okay, in the meantime, do we ever set that? Okay, let me just make sure. Status LEDs, main.h. 1 and 2, clock to 1, data to 2. Clock is green, and data is white. And let's get the multimeter out and make sure we're actually getting power to that. Okay. Workbench mode. Let's go to workbench mode. Alright. So, ground and power. Yeah, we got 3.3 volts. That should be working. Examine that. Yeah, those joints do look good. Why did that disconnect? What did disconnect? I'm not sure what actually disconnected. Something disconnected. It's still downloading. Why is that so slow? Oh, wait. Installing crap. Gonna test it again. Hydrate, and let's go to the Havsy screen. Because the LEDs are visible. That is a strange amount of lag, though. Alright, let's see. Uploading code again. That is still installing. Are we like returning early or something here? Just give a else. Drink some water. It's not even printing those, which is... huh. You know what's going on. But why is... platform IS set monitor. Okay, I think that's the thing that we want. Maybe it was working the whole time, we just had the wrong monitor set up. That would be annoying. bloop, 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 bloop. Thought I already set it to that value. And we'll see. Oh, you know, it's possible, though, that the Arduino IDE is actually intercepting the serial monitor. No, that's not happening. Okay, we'll just set board to ESP32S3 dev module. Oh my gosh, that is a lot. It's probably port 16. Okay, let's just copy paste the raw tutorial code on there. Although, load cell data pin should be 2, and that should be 1. Let's call it load cell calibration. Compiling. Why are we not getting outputs, though? Hydrate. Now we're not, like, getting any output logs there. Oh. We need to add that library. Libraries. Updating list of libraries. HX711. No, it's not even done yet. Alright. We want the one by this dude. Installed. Come on, just close out. Okay, there. Filing. Compiling. Why is it taking forever? This is a long time to compile. Okay, now let's upload. Come on, we just compiled. Why do you have to recompile? Just upload what we just compiled. Okay. We're still not getting anything back from it, though. It's kind of a problem. Okay. Kia device monitor. What if we reset it? that's not even the right, thingy. Okay, let's not do that. Okay, serial monitor, it should actually be that odd. Great. Alright, let's try again. Serial.println. Hello. We'll just screw that for now, and let's just see if we're getting anything out of this, because this is not normal. You know, it'd be cursed. We could actually just log to Twitch, to the Twitch. Yeah, we could just log to the Twitch chat. That'd be kind of hilarious. What if we just... Okay, I'm gonna do that, because that's kind of funny, actually. Where are we saying dispensing water? It's up here. Okay, this is gonna be cursed, but we're gonna use the Twitch chat as the debug log. Twitch channel. This is really cursed that we're doing it. Alright, let's see if this actually helps us to Twitch. Where's the part where it would also just say, water? It's actually not going to work because is there a flag I forgot to enable for serial monitoring on Platform.io? Because, you know, that's probably actually a better thing to check than using Twitch to debug the logs.
again. Serial begin. Seriously, why is serial logging not working though?
I thought I did that already. I didn't. It doesn't explain what's going on with that one either. Let's just upload this and try again. If it even wants to, like, show up. Which I don't think it does. Connecting, connecting, connecting. ESP32 S3 serial not working. Yeah, we're not getting anything out of there. Let's just have LED load cell. Load cell status, load cell status. All right, and status. Make it like full red. And if it's good, let's set it to full green. And I need a pee, so I'll be right back. PP time. Okay, I'm back. Did we upload that program? We did. Let's make sure all the LEDs are visible here. Let's go back to Halvesies view. I did not want to move that. What? Where did I go? I ruined the Halvesies view. It's okay. No, really, where did my view go, though? Oh! Well, I'm big here. Okay, let me just... I don't know what I just deleted, but I deleted something. Okay, that should work now. GoPro. There we go. Okay. So... Oh, we never set the load cell status. That makes more sense now. Where do we set... Load cell status ready. Okay, but it also still weirds me out that, like, we're not getting the, serial stuff working. Okay, but that turning green does mean that it does eventually get ready, though. So, it is working. The thing that's not working is serial out. But I think I know what to do here. Load cell. This is false. So we only want to run this once. And let's have it so that we do this as soon as we are connected to Twitch. And then let's do the dumb thing and use Twitch as the debug logs again. This is really dumb. But we know that Twitch is outputting correctly, so... So this will probably work. Alright, we'll probably have a bunch of random Twitch messages dispensed now. Hopefully. We did not. Damn. Did we? Let me just check. Twitch.tv/Pearl Gray Skies. Sometimes it looks like there's like a delay when there shouldn't be. Oh. That's because I didn't prefix it with the right thing. Okay, that makes more sense now. Because that is supposed to fill into here. Not ready. Waiting. I don't know how that's pronounced, if it's Tare or Tare or something else. Or awaiting empty. Awaiting known. Or I guess awaiting calibration. And then you don't need to two messages here though. Let's increase this delay to 10,000. Ready. So I guess let's go. Red, blue, yellow, green. Yeah. So, awaiting calibration. Let's make that 255. And awaiting empty, let's make that yellow. Okay. That could work. Uploading. Alright, let's see. We're yellow. It's not saying anything. Oop. It didn't say anything. feeling really dumb right now. Do we do another, like, first-hand S? That might work. May have forgotten to put that stuff in there. Okay, let's try this again. Get anything out of the Twitch? We do! Or at least we have it say water. But it's not saying anything else! Oh. Never mind, it is. Okay, cool. Weight is on the scale. Why is it saying water again? Oh no, it's doing a weird loop. Can we just get the fucking thing to work? Oh wait, you know what? What if we just... could work. Okay. Let's see if this actually dupes the dupe. Because if it completes, then it should turn... Oh. Nope, it does not. It just keeps repeating. Because it should finish at green, but it never does. Alexa, set lights to purple. not poggers. Scale. Yeah, we should really probably just figure out why the serial monitoring is not working. That'd probably make our lives a lot easier. Yeah, that might be it. We don't have that. We don't have this build flag turned on. That may have saved us like 30 minutes of pain, but such is coding. So platform is Expressive 32. Our board is that. We're doing Arduino. I guess. I don't know about that. Okay, let's just upload this and see what happens. Go back to that one tutorial that we're looking at, the random tutorial. We get tutorial. I know what's going on. I know what's going on. It's because Arduino IDE is taking up all the dookie. Not getting serial logs though. Wait, unknown configuration option in that, but what? It's probably because it's not on the same line or something like that. Let's try this. Yay! We have actual debug logs! We have logs! Oh my gosh! Ah! That was frustrating. Okay, let's get back to this bullshit. Whatever. Let's get back to the calibration stuff. Okay. Let's just ignore all that other crap and only worry about the damn scale stuff. Okay, replace this with load cell. Load cell, load cell, load cell. Upload and monitor. And let's put us back onto Havsies mode. Whoa. Okay. Hello? Remove any weights from scale. Cool. Place a weight on the scale. And we don't want to use this. What? Why did it stop? Okay, what? What's going on? Unless. Okay. Let's. Okay, so setup. We are setting load cell status to that. Waiting empty. Awaiting calibration. And ready. Should be getting some kind of error out for why it's not actually getting a reading. It says hello, it says remove any weight from scale. It's done. Remove weight from scale. Place a known weight on scale. Remove weight. What? Why is it restarting? Oh. And it may just be because of this delay thing. We also just... It might be because I commented it out wrong. I'm not sure. Hello? It's not found. Remove weights from the scale. Doing that. Place it on the scale now. Wiggity wiggity whoop. Remove it. Place it on the scale. Wiggity wiggity wiggity. What? you're getting inconsistent readings. That's not good. Well, it also may be because we're on, like, the... Oh. Well, it also could be because that could have been unplugged. Let's replug that back in and see what happens. And just leave it on, like... I think it died. Let's press the reset button. That's not happy. Okay. It's not happy. It's not happy. Why is it looking at serial port 4? Oh no, it's looking at the wrong port. Does it hold boot and then reset? Remote go? This is the wrong port. Something is unhappy. There we go. We have port 16. Okay, I think we're just gonna let it loop a few times just to see what the... Hello? Not found, not found. Okay, remove from scale. Place weight on scale. Remove. Place weight on scale. Alright, remove. We have consistent readings now. Place weight on scale. Wiggity wiggity wiggity. Alright, remove. Place weight on scale. We're gonna switch to this one after that. Okay, removed. Place weight on scale. So I think maybe it just came unplugged and didn't realize it or something. Alright, remove. Place weight on scale. Alright, remove. Place weight on scale. And remove. Place weight on scale. Alright, cool, we're good. Alright. So what does this mean? So these first 4 results are from, I believe, 500 gram weight, and then the next ones are from 200 gram weight. And I wonder if it's scaling linearly, because if it is, that'd be nice. If it isn't, then that's dookie. So, let's see. 3, 4, 9, 2, 3, 0, plus 3, 4, 9, 347 plus 349, 348. That's really close. Plus 349, 4 divided by 4. So then the average is 349,337. Now let's do 139,858 plus 139,888 plus 139,869 plus 139,823. Divide that by 4. Okay, so the two numbers that we have are bloop bloop bloop. Oh man, if y'all saw that controversy recently with opening Notepad, but it's okay because these are totally normal ass. Oh wait, damn it! Did I just show like no? I just showed some OAuth codes. I'm gonna have to delete that VOD off Twitch. Oh well. Anyway, and I try to be funny, and I mean, it's better to reveal security secrets on like a throwaway not throwaway, but like on a test project than it is to to be caught with what that one guy was caught with. Anyway, okay, I'm writing down the numbers. So I'm really hoping that this is 40% of this number. So let's see if that is true. Okay. 9337 139,859 divided by that. What the hell? Okay. 8 divided by 9337. Hell yeah! It's linear! Look at that! Oh my gosh! Look at it's basically almost exactly 40%. Almost exactly 40%. That is amazing. Ah! Okay. Anyway, we have a good calibration value now. So, let's see. Let's get this. Okay, so I wonder why the rating's negative. That's weird, but anyway. Okay, so we have this number from 500 grams. So, let's do that. Divide by 500. 349,337 divided by 500. And our calibration factor is 8674. Okay. We'll save that then. Fine. Load cell. We'll just call that load cell factor. Okay, cool. Alright. Weighing objects. So now we know that. And we could probably do a thing where we just divide that by load cell factor. I bet that we'll actually get some good readings. Alright, remove weights from scale. So when you put this on, we should get 100. Or no, 500. It says that's 500. Alright, let's put a new one on. This should be 200. Perfect! Let's stop that. Yeah, this is exactly what we want. It says that the first one was 500 grams, was 499.94 grams, which is close enough to 500 grams. And honestly, these are like $12 calibration weights. So I don't expect them to be on the dime exactly what they should be. But we have the numbers that we want here, and that is great. We really like great numbers. Yeah. So, what does that mean? Well, we have our calibration factor now, and it's just straight up linear, which is super easy because we don't have to calculate some bullshit curve or some bullshit. So, we can get rid of this stuff. Okay. Cool. Alright, so what does this actually mean, though? Okay, so I think that when we initialize the scale, we should, calibrating the scale. Okay, so let's just make sure that the... Oh no, that should be set to not ready. So while... it is not ready. So we'll just wait. And then I guess we can do serial print line, it's ready. And then, let's see. Load cell dot set scale, and then set load cell status, awaiting empty. Woo! Woo! Yeah. And so we don't need to get the reading anymore because we know what the state should be. So we just need cell, done. Okay, so that should mean that's ready. And then here, we should just get like a... We should just output what the current reading is. Void output current. Wait. Measurement. Or no, I guess... Not log, not calibrate. What's... Read weight. Yeah. Read weight. And then here we can just have it serial. No, we don't want to do that. Long reading. Load cell dot get units 10 sure. Print current weight. Cell factor. Print that. I forgot how to do formatting. So whatever, we're just gonna do that. Cool. And I'm gonna go pee. I'm back. Okay. That should work, I think. Are we actually reading weight? We are. Should probably save that weight somewhere. Load cell. Okay. I guess float current weight measurement equals 0.0. Read weight. Okay, that might work. Let's upload and monitor that. Hello. Load cell initialized. Connecting to Wi-Fi, connecting to Twitch. Now we're just measuring weight. Okay, cool. That's what we want. Okay, let's just say something close to 500. Are we close to 500? Yes, we are. That's some good shit, Pecco. Alright. Should be back to 0-ish. We are. Let's go back to 200. That's some good shit, Pecco. Alright, this should read 100. Yep, that's close to that. You're missing... Oh, that's another 100. Okay. Where are you? You're 50 grams. Okay, 50? Yep. Alright, so... I think a real test here is... Put this glass on here. That is 349. And let's confirm that with, like, a real ass scale here. Or, did I say 349? I can't read numbers. Okay, that says 398. And on here, we see 396. Actually, let me go put us on half-seas mode. There we go. And let's... Yeah, okay, that's good. Alright. So... I guess the maximum case is when all the water is in here. So... let's fill it up with water. It's not plugged in. Alexa, set workbench light to white. Alexa, turn workbench light on. There we go. Oh. Okay. So, this is pretty close to full. Cool. Alright, so when we're here, it says it is 814 grams. Here, let's make sure that we're close to 814 grams. 814 grams, exactly. That is perfect. Okay. I'm gonna just put that kind of in there so that we don't, like, spill it, I guess. Return some of the water supply back to the water. Okay. Let's return it anyway. Okay, that's cool. Alright. So we have the weight going on. And let's see. Let's have it so that, why did we stop recording? That's not good. Unless, did it just stop strong or something weird? Let's try again. Why did it stop? That's weird. Did we, like, splash some water on it by accident and now it's dead? Maybe not. Okay. Bit of some monitor. Okay, cool. Yeah, that did not happen. That's good. Alright, so there's nothing on the scale. It should be whatever that is. We have a glass on here with maybe a little bit of residue on it. Let's define. I'm gonna go change this back to whatever that should be. Okay, so let's define mass empty glass. 9 grams. What's going on here? Okay. Fine mass glass tolerance. Let's see what happens if we just give it a splash of water. Oh, we unplugged it. Because they're smart. Probably. So just a little splash of water. That's about 20 grams. So let's make tolerance about 20 grams. Cool. Okay. So that should mean read weight. Where are you? Read weight. Let's see. Glass status. If current weight measurement is smaller than mass empty glass plus mass tolerance. Or, you know, actually we want to subtract that a bit. Maybe that should be like 10, actually. I think I thought about it backwards. Cereal? No, not you. The lady inside the iPhone heard me say that word partially and responded. Okay. So, serial print line. Or, yeah, print line. No glass. Else, if current weight measurement is smaller than. Did we ever weigh how much a full glass is? I think we did. No, we didn't. Let's. Thought we weighed that. I guess not. Okay, well, let's get a full-ish glass then. And we can test out how the overflow thing works. If it works. Okay, let's get some paper towels prepared ahead of time. Doop, doop, doop. Okay. So, yeah. Oh my gosh, I was actually kind of right on the dot there. Well, let's take that measurement. This measurement is 857 grams. Define mass glass. Full. Let's make it 875. Define mass glass full. glass tolerance. Nah, let's just do 10 grams, just be safe. Anyway, yeah, that should probably work. Alright. Minus mass glass tolerance grams. This naming convention probably doesn't make sense. Else. What? Serial.print line full glass. You know, let's actually set. No, let's have a thing. Nah, it doesn't matter. Okay, cool, whatever. I want to test out the overflow thing because I haven't gotten to do that yet. Let's do that. Whee! Oh. Whew. These walls should probably be higher because it's not draining fast enough. But it is working in general the way that we wanted it to. So that is good. And I noticed there's a bit of splash here, which is not great either. But yeah. So we do have some additional mass though from the water that's just hanging out in that area. Yeah. Okay, but in this state though, we should be able to see what the glass status is here. So let's terminate this. Oh, I just realized Doc can't even see what was going on there. Okay. Just realized I'm gonna have to figure out how to actually get. Oh! It could be cheap. Oh, no, wait. Wait. What if I did this? Then if I did this, then if I did, oh, clever! I'm so smart. Okay. Let's pour that out. I'm not making as much of a mess as I thought I would today, and that's good. And let's try this up, I guess. It's unplugged. I should probably hot goon that. Turn back on the hot goon gun. Okay, what have we not hello worlded or figured out yet? That is important. Gun is heating up, and I am checking the okay, we designed and printed the frame. We have hello worlded the load cell. Now we just need to trigger the water pump and modify the program to dispense water. That was reasonable of me. Yeah? Alright. How the heck am I gonna do this? We need a MOSFET. Alright. Where are my MOSFETs? MOSFETs. At least MOSFETs look distinctive. It's hard to miss MOSFET. I'm pretty sure I have several MOSFETs. MOSFET. Where are you, MOSFET? Wait, if I don't, I can actually use one of those, relays that, I got a while ago. And, you know, I can't actually find my MOSFETs, so we might have to. Electronics misc. Do I really not have any MOSFETs just laying around? It's kind of crazy if I don't. I thought I did. Non-glue, non-resistors, not that. You know, we might actually have to use the relay. That's okay. I think the relay probably works for this. If I can find it. Relays, where are you? No, that's robot bag. And this is, the Pearl Grey outfit bag. Hold on, I am looking for the other project bag from last week's project. Because I put the projects in bags to make them easier to compartmentalize. Ah, it's here. Yeah. So here's one of the relays. Alright, so this isn't exactly what I planned for, but it just still work. I'm gonna take one of the relays, and there's water in the breadboard, which is not a good thing. I think I'm just gonna skip the breadboard here. Okay, so what is this relay even called? This relay is... it's not on the label. It is on the other side of the label. Okay. So you are SIP 1A05. And... okay. Yeah, so the two middle ones are the input, and they close the two outer ones, the output. Easy enough. So, yeah. Let's... okay, water is blue. And let's hook up the other side to ground, I guess. And then... the other, it does not matter the polarity for the other two. Cool. So... let's chop that wire here. The Omnifixo to do Omnifixo things. And heat up the soldering iron. Heat it up. Okay. Oh, this one's crusty. I think that's one of the ones I messed with. at the start. That's okay. We can reuse it. And the hot goon gun is on, so we can unplug stuff, and then we can make that one connection a bit nicer. By nicer, I mean more secure, but actually kind of uglier. It'll work, though. Hold on, which one is pin 1 and which one is pin... Okay, so we want positive to be... Actually, not even sure if it really matters, but whatever. Put negative needs to be on the right, positive on the left. And then I will, what will I do? Would it be easier if I tinned those first? It might be. Tinning those. Okay. Cool. Let's actually move this like very, very way more closer. Alright, and move this a little upper. And just consulting that. Plus and minus. You know, it doesn't have to be at there at the same time. There's a reason for that. Let's just make them touch tips. Okay. And as far as the other side goes... I don't know, that could have been dookie or that could have worked. I want to think it worked. It's ugly, but it probably works. I mean, the wires are just hanging out like that, so I'll say that worked. Let's heat shrink that. Okay. Doop. And doop. Alright, that should be good enough. And so when we trigger the pump, then we should set that to high. And then that will make these two close. And, yeah. What next? I guess we're gonna tear out the switch from the pump, then. Yeah, let's do that next. Switch, pump. Bye-bye. that's exactly what I thought it'd be. Just a power and a ground. And then here, can strip that. Well, I have to use my finer wire stripper. Yeah. And then it's twisty, twisty, twisty those. So, it's actually really silly, but one of these outs is actually 5 volts. So we're gonna tap into that from the LED. Maybe. No, that sounds like a bad idea. Can we just test if... Ugh, I don't like this. You know, let's just get 5 volts from a temporary other source for now. You know, ironically, that could mean we bring back the that USB cable that I just threw away because I was being silly. Where did you go, USB cable that I threw away? Fuck you! Alexa, set lights to white. USB cable, where did you go? Yeah, I literally just yeeted that chunk of USB cable. There it is. Okay. I'm gonna do the same thing. Cut that out. And then open this up. Okay. We have to splice ground to ground, and then we're gonna put the relay switch over at that one on the power. Okay. Is there a proper way to do this? Nope, I'm gonna go jank. Because I can't bring this down to the OmniFixo. It's okay, we're prototyping here. We're gonna redo this nicely later. But for now, we're just gonna deal with this. It's weird, this smells like weed. It's not weed, though. Alright. So let's put some heat shrink on that. Well, I don't know, let's maybe just, like, cut that little sharp bit off. So I've had solder poke through heat shrink sometimes in the past, so I'm a little paranoid of that. I'll use a lighter. That'll work. Ooh. Okay, that should be safe. Next, want to connect this to the relays. You know, actually, I just want to use some, like, scrap wire, because this is temporary. I want to waste some good virgin wire. That'll work. This random servo connection thing. Actually, that might be too fine. Nah, it'll work. Okay. Is this silicone? It is, I can just pull it off. Okay, twisty, twisty, twist. Been a little too long. Actually, I think, yeah. Ground should probably be on that top end. Actually, I should wait. I should connect it here first and then do that. Yeah, let's do that first. Okay. So this first wire here, I'm going to connect it to here. I forgot to actually put heat shrink wrap on that. Damn. Okay, hot goon gun. Who needs heat shrink when you have hot goon gun? Alright. This other one here. Okay. Why the fuck does it smell like weed? Why does rosin smell like weed? Okay. You have hot gooned that. So now I think that what we do... Oh, wait. Oh, no. We still need to, connect those, I guess. No, we don't need to connect those right now. And I just want to freeze these real quick. Okay, that should freeze them by now. Alright, let's connect one of these to ground and the other to some random ass pin. Let's make that, pin 18. Cool. You are pin 18. What's up? And then... No, actually, let's just hook it up anyway. Why not? solder that. And then we'll hear some when we know it works. That is nasty. Alright. You know what's coming. Hot gun gun. Okay, cool. Let's not. You know, that actually does not look satisfactory at all. Let's do it for real, for real. I didn't fuck it up by... Nope, I did not. It's still pliable. Yeah, that was a bad idea, actually, to use the hot glue gun for that. Alright. Cool. That should work out now. You just like to squeeze the tip. Ah. Alright, now we can, let's hook this up to here. Let's put it on that side so it's not as stressful on it. Okay, let's actually do pin 36. 36 is a nice number. Okay. Oof. So, let's have it so that the pump duration is just like 1 second, just so it's not like too crazy. And then let's... What are we gonna call this? Fine. Pump output pin is 36. Cool. Which read, wait, pull, blah 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 blah. Initialize. Initialize pump. Nope. Should probably have the pump initialize first. Because we don't want to like turn on and then just start pouring water. Okay. Is it set output pin? Arduino set pin output. Oh, pin mode. Pump output pin output. Okay, cool. And then we set that to low. you know, actually... What if we just set that to high, and then else low? And then let's plug that in. And just sanity check that it's going to ground, that's going to one of those pins. The outer two are isolated. And we'll be going to here. And let's put a glass of water down here. Okay. And if something goes wrong, I'll just unplug that manually. But let's upload. See what happens. Alright. Hello. Load cell initialize, connect to Wi-Fi, connect to Twitch. Okay, so what happens if we type in hydrate? Let's go to halvesies mode. And change the focus to there. Okay, if we do hydrate, oh, that works! Wow. Okay, I see you. Although let's reset it because this had water in the glass already, or no. That made no sense. This had the glass on while it was initializing ready. And that threw off the weight measurement. Alright, now we're here. Okay, so we can also debug the glass status. It says there's no glass on right now. Let's put it on. It says that we have a partially filled glass of some amount. And then let's hydrate. Oh no, I didn't put the thingy. Hydrate. Whee! That works. Cool. Okay, I'm gonna unplug this thing so that people don't spam hydrate and make this thing overflow because we don't have any safeguards yet. Yeah. Okay, so I think that we should probably figure out how full the glass is and just log that. Okay. Auto. Total possible water mass is equal to mass glass full minus mass empty glass grams. And I should probably add grams to that too. Yeah. Auto. Total water mass. Water mass alone. Grams. And let's also rename this to grams. Is equal to current weight measurement minus mass loss empty. Then if water mass 11 grams is smaller than 0, then is equal to 0 grams. We don't want negative weight to be weird. Okay, so auto glass fill percent is equal to, oh wait, let's also have if water mass 11 grams is over that, then so that will clamp it so that we don't get super duper 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 weird values. Okay. Glass fill percent is equal to water mass 11 grams divided by total possible water mass, or fraction. Auto glass fill percent is equal to glass fill fraction times 100. Serial.print glass fill percent. Serial. Yeah. Cool. Alright, now we can upload this. And also get rid of the water in there. Hello. Alright. We're initialized, we're connected to Wi-Fi. We have weight 0. And now we have partially filled glass 0-ish percent. And then we're gonna go plug this in. And then we're going to hydrate. It's gonna spit out some water. And that was 14%. Hydrate again. Cool. Okay. Float, current, water, fill. Which means that this is going to be equal to 1.0. This is going to be equal to 0.0. This is going to be glass fill fraction. Alright, now we're adding some safeguards. So if also have it that bool glass exists equal to false. True. Oh no, this should be false at the start. And I don't know, I just like having more explicit values. Else. This is probably redundant or whatever logic or something. That should not be percent, that should be fraction. Yeah. Glass full should be true here. Cool. Glass exists and the glass is not full. Else. Cool. So that should safeguard us so that if the glass isn't there, or if the glass is full, then we don't pump. Otherwise, we pump. I need to pee again. I'm back. Okay. Let's see. So, yeah, I uploaded the program. It says that there's no glass. Let's go back to the halvesies thing. It's been a pretty good view. Halvesies. And it's gonna say that there's no glass right now. And now it says that there is a glass. And then let's hydrate until it's, well, actually, first let's make sure that it's going to how do we set this up? Okay, so I'm gonna type hydrate, and then I'm gonna hold the glass of water while pressing enter. And we don't dispense because it doesn't detect that there's a glass on there. Now, let's try again. Hydrate. Okay. What's the maximum weight? When it's completely full, we have 800-ish grams. So let's take one of our calibration weights and just put it on at the same time. Or just the smaller ones, I guess. Okay, it says it's partially full. One more. It says it's a full glass. Let's hydrate. And we do not dispense because it's full. Let's take one of these away. Let's hydrate again. And we are dispensing. We're not full yet, so we can probably hydrate one more time. And we cut off once we're full. Cool! Safeguards are there. Amazing. Alright, what is left on the to-do list? Have we fulfilled the to-do list yet? First item, design and print and assemble the frame. We definitely did that. Hello world, the load cell. That's definitely working. Trigger the water pump. That is working. And modify the program to dispense water. That is working. Cool. Yeah, that actually completes our to-do list. We have an MVP right now. Minimum viable product. Yeah. Alright, I mean, I think everything left is kind of just in the code, maybe? But I just want to clear everything so that we can get some nice shots of what's going on. And just take those weights off. There's a thing I wanted to add. I want to add a beeper, though. How long has this stream been going? 4.5 hours. Maybe I'll save that for later. Yeah, I'll save that for later. I'm getting tired. But let me go clean off this stuff so that make like a pretty decent little reel of what's going on. Bloop. Okay, how about the lighting? Let me just clear this debris out of the way. And that. Set the angle. And yeah, let's just go for the big ass nice view. Alexa, turn workbench light off. Okay, and let's set camera mode to manual. Yeah. What if I turn the ring light on? Does that help? I just want a nice clear angle so I can make a reel from this. Let me go get a little backdrop. this. That'll work. Okay, cool. Let me just write a test thing. Test. Oh, okay, yeah. So it does show up, but let me turn off the bamboo view. Okay. So, yeah, let's just reboot this thing. Reconnect. All right, demonstration of how far we have gotten. All right, so right now it says that there is no glass on the dispenser. Now it says that wait, you know, actually this would probably work better if we actually had like LED colors. Let's do that first. Okay. Status LEDs. Let's have these mode. Twitch status, pump status. Off. No glass. Active. Glass full. Sure. Pump status. So if we have no glass, then let's make it go, I guess, red. Maybe actually yellow is probably better, yeah. And if we do have a glass, but it's full, then we should set it to that. Cool. Cool. Okay, let's have it so that, what are the cases that we have here? So if the pump is active, and then we can set this pump status active. Else, if glass exists, and glass is full, then that means that pump status is glass full. Else, if actually, we don't need that. Okay. Else, if the glass does not exist, then set pump status to pump status no glass. Yeah. Otherwise, initialize. I guess we'll just copy paste that logic and figure that out later. You can make it clean later. I have a syntax error somewhere. Status LEDs up each. Ah, it's in here. Is it there? Ah, it's here. Okay. What if we turn on the ring light? Yeah, that looks a little better, I guess. Cool. Alright. Now is this what we want? Load cell initialize, connecting Twitch, blah 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 blah. Okay. Oh. Let's reset that actually. Should probably be able to figure out if there's a glass on there. Because it's definitely gonna reboot with the glass not on there. Okay. So I think we can do the demonstration now. Alright. So if we have no glass on here, the light is yellow, and when we try to hydrate, it refuses to dispense water. Now, when we have the glass on here, shit, it doesn't work. Oh. It's because I forgot to set the light. Okay. We might be able to demonstrate it for real now. I think I'm gonna turn that light down, if not off. Alexa, lights off. Oh, that's a lot better, actually. That's kind of moody. Alexa, set lights to purple. Alexa, set lights to purple. Oh, yeah. Yeah, that's the beans. Alright. So, when we have no glass, the LED is yellow. And we put a glass on, then it's pretty good, I guess. Actually, we should probably add a pump status for ready. Yeah. And in this case, let's just make it green. Oop. Yeah. Okay. For all this time. Doop, doop, doop. let's see. Okay. I think this will work now. So, when you have no glass loaded, that LED is yellow, and when you try to hydrate, it just won't dispense anything, because it shouldn't, because there's no glass here. I'm gonna put the glass on here, then that turns green, and then when we want to hydrate, it should dispense water that I have to drink. And we can hydrate again. I'm gonna copy paste that. More water! More hydrate. More water. More hydrate. More water. More hydrate. Whoa, what the fuck? I didn't expect that. Let's try again. Oh, I know what's going on. Somehow the thing creeped up. Okay, let's stick it back down in. Okay. More water. More water. More water. Shit. It's like really close to the edge. Fuck it, let's just see what happens. Because it says it's like 95 point whatever. Okay. What happens here now? Okay, dispense water. Okay, now it detects it's full and it stops dispensing. So that's good. Yeah, you can tell because that light is red now. And let's try to hydrate again. It just refuses to because it's full. Okay, well that works. Cool. Yeah. Well, I guess that we have a thing that forces me to drink water, and I'm gonna go drink this water now. Somehow. I'm making a mess. Ooh. Yeah. Cool. Doop, 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 doop. And we can do it over and over and over if we want to. Alright. Well. I think that was a stream. And, let's go back to office mode. Oh wow, my feet stopped tracking. Let's fix that. Turning the... Oh. Did all my trackers stop tracking? Okay. Well, we made a thingy that dispenses water when you type hydrate in the chat. And that's pretty poggers. Cool, yeah. I'm streaming on Tuesday and Thursday and Sunday. So, yeah, I don't know what I'm gonna do yet, but I'll figure that out and then I'll post a schedule soon. But, yeah, alright, well, thanks for tuning in. This was fun, and then y'all can force me to drink water. And, we're gonna take this very, very, very rough prototype, and we are going to make it look very, very nice in a future stream. I actually really, really like this project, so it'll be a very, very soon stream. But yeah. I'm tired, so I'm gonna end the stream. But yeah, alright, well, I'm logging off. Bye-bye.